Hey everyone, this is Matt Perez with Converge, and welcome to part 4 in our sketch block series. So far we've covered the creation and usage of basic sketch blocks, and our example was a DB9 connector or a DB style connector. Next we covered the belt and pulley layout functionality and how we could use that to engage the belt, and also how to create solid bodies from those blocks. Then we talked about gear layouts, and we did an example of a basic gear drawing circles for the pitch diameter, and then we used some more complicated sketch blocks that actually had the teeth of the gears, and we looked at ways that we could engage those. We also briefly talked about the use of engaging to talk about rack and pinion gears as well. So now what we want to talk about is linkage, and this is another big application of sketch blocks. And this is where you can really save a lot of time designing your linkages, assuming that they are in 2D. When we talk about a basic, let's talk about double wishbone suspension or double A-arm suspension. That is something that we can essentially break down to a 2D view. Obviously, we can't talk about bump steer and things that happen with the steering that's in another plane or in another axis. But we can talk about the basics of the layout of the links and understand the positioning of those and how they affect things like the roll center or instant center of where those links meet in the center of the car body. So we're going to get started with a brand new sketch, and again, pick whatever plane you're comfortable with. Then we want to insert a block. So we'll go to Tools, Blocks, and Insert, and go ahead and navigate to the supplied wheel and spindle block, and we're going to insert that into our sketch. And don't worry too much about positioning right now, just place it off to the right of the origin a little bit, and then say OK. Now that we're inside of this sketch, this block is free to move about. It's not fixed in any way, and that's exactly how we want it. We don't want to fix the wheel and spindle combination. We want that to be able to move. However, we do need to figure out the ground plane where the tire is going to be. We also need to figure out the location of the suspension points. Now, this specific example can be a little tricky because you may or may not want to replicate the body of the vehicle moving, or you may want to just replicate the suspension moving up and down. So we're going to talk about moving the suspension up and down, assuming that it's moving away from the ground. But there are ways that we can sort of play around and use things like tangency with a ground plane and actually move the body up and down of the vehicle. So keep that in mind. There are some things that we can do there, and we can see how the wheel travels. But we're going to focus on moving the wheel up and down and having fixed pickup points for the suspension. The way that we're going to do this is by using simple points. So for the upper point, I'm going to place it to the left and a little bit lower than that upper suspension point. And for the bottom one, I'm going to take it a little bit farther in on what would be the car body, and I'm going to make it roughly horizontal. I'm not going to apply any constraints here. We just want to get it in appropriate locations for what the suspension would be. Then I'm going to fix both of those in place. So I'm simply going to grab them and I'm going to make them fixed. And ideally, when you're planning out suspension design or linkage design, you want to know the locations of these, and you want to be able to drive them based on dimensions. It's a bit outside what we're talking about here. We're not actually learning how to design suspension. We're just learning how to use sketch blocks. So what we're going to do is we're going to create some new links. Now this can be very basic. It can just be straight lines, and this can also be more complicated where we can actually draw, for example, a slot as just a basic representation of that link. We could get a little bit more complicated and add things like pickup points for suspension if we want to know exactly shock travel, things of that nature. So for example, on this lower link, which likely would contain the shock and the suspension members, we could put a point here, and then we could create a shock itself with just a basic representation. Again, we will just create some lines here. We'll carry these up, double click, and we'll do the same thing on the top. We'll create a couple lines, and then we'll draw another member here. Now the reason I'm doing this is I want to represent the actual shock itself, not the spring necessarily, but I'm going to make these two members perpendicular. Then I'm going to make these two collinear. And then I'll do the same thing up here. I'm going to give these a midpoint constraint. I'm going to make sure that this is perpendicular. And I'm going to make sure that these two are collinear, which they already are, but we'll apply it just in case. And now I can convert these into blocks on their own. Of course, we can add dimensions and things of that nature, but what we want to do is we want to simply replicate the motion. So With that suspension in mind, we need to also add a point that the suspension on the upper portion can attach to. And again, that's going to be fixed to the car body. So we're going to go ahead and fix those 3 points. So now we need to convert these to blocks. So I'm going to make sure I grab this lower slot as well as that point we added, and we'll make that a block. And remember, we can hit enter on the keyboard to OK that selection. We can also hit OK in the properties, and we can hit OK in the upper right hand corner, or the confirmation corner. So let's go ahead and grab these 3 members. We'll make them a block, and if that option disappears, again, you can right click and use make block. You can also turn on your block toolbar if you like to have those accessible. And just as a note, this tends to pop up from time to time when you start using blocks automatically. So sometimes it'll pop up and it'll just be there anyways. All right, now that we have all of these created, we can start to build out the suspension. And the first thing I'm going to do is I'm going to take this point and I'm going to make sure that it's coincident with my suspension member. So you see now that moves up and down. Then I'm going to take this end point and I'm going to make that coincident. And now you can see that we can start to move things up and down. You can see that the actual wheel and spindle itself is not articulating because we haven't connected all the links yet. The next thing that we're going to do is we're going to take this upper link, we'll snap it there, and we'll grab this upper point, control select, make those coincident as well. So obviously the positioning of these points is way off. Obviously that's not a situation that we would want for suspension. But that's okay, don't worry about that just yet, we'll fix it. The next thing that we're going to do is take the lower portion of the shock, we'll take the upper portion of the shock, and then we're going to connect one of these points to the other line, make them coincident, and then we're going to make sure that they are collinear. And the next trick that we're going to do is we're going to apply a dimension from here to here, and we can drive this dimension, which will articulate the suspension, or we can right click on it and we can make it driven. And that way, as the wheel moves up and down, we can see how it affects the overall travel of the shock itself. So this will help you do things like pick out the amount of suspension travel that you actually need. All right, so now let's fix a few things here. We need to fix this upper link. So I'm going to edit, and I want to make this a bit shorter. And again, we would typically drive this with dimensions. We're going to say OK, and notice that it snaps into the right location. Now I'm going to take this lower link, and I'm actually going to make this one a little bit longer, and it pushes that bottom out. So now we're in a much better situation where at a certain point in the suspension travel, the wheel basically doesn't have any camber, and then we can travel up, and you can see that we do get some camber gain. Just a little bit. And of course, it depends again on the design of the suspension. And we're not really talking about that topic. We're talking mostly about the application of sketch blocks. So from here, there are a few additional things that we could also do. I'm going to add a few more lines. I'm going to go from this point sort of just out in space, double click. I'm going to go from this point out in space, double click. And what I want to do with these lines is I'm going to make their points coincident at the end so we can merge those points. And then I'm going to make them collinear with the center points of these slots. All right, so this is an important factor when we're talking about suspension, is understanding where we have that virtual point that these two links connect to. So it's a key point in understanding how the vehicle handles changes in suspension travel and what that's going to do to the overall vehicle. So having this point, we can then get a dimension from it. We can understand where that point's going, what the angle is in relation to the ground, and how that affects the overall suspension. So now I want to get this to be a little bit more realistic. So what I'm going to do is I'm going to adjust this upper point. So this upper point that is fixed, I'm going to delete, and I'm going to start to manipulate it so that it is mostly parallel with this lower link, and then I want to fix it again. So now that it's fixed, we have a little bit different idea on the suspension travel. You can see that it moves up and down, and everything looks pretty good. So we can understand the travel of the suspension. You can see that the suspension, obviously the angle is not correct. So what we're going to do is we're going to bring that point back, something a bit more realistic, and then we'll fix it again. So now we can see exactly the travel of the suspension. We can see everything move up and down, and we can identify exactly how it affects the overall geometry of the design. And what you would do from here is you would take this information and understand where the points on the frame, the chassis, need to be. You'd understand the length of the links that you need and maybe the geometry of the spindle itself, and translate that into a 3D model. Unlike belts and pulleys or gears, this is not as simple as just extruding this out in 3D. However, if your upper and lower A-arms are going to be in plane, if you're not going to have any additional tilt or angle in relation to the body, then you can simply use these to create planes and work from there. If you are going to have those changes in 3D, essentially, if you're going to have the tire move up and back at the same time, and you're going to have those changes in caster and camber, well, then that's something that you need to account for in another sketch block from another view. So you can look at that from, let's say the top view or the side view, and see how those things adjust in different planes and different views, and help really just drive the overall design and understanding of it. Now, obviously, this is not a 100% replacement for all linkage design, because something like car suspension is very complicated, especially when you get into multiple angles and understanding that the connection points generally between the links and the spindle itself are going to be ball joints or some sort of joint that is free to move and not just a single plane like we're talking about. But it does give you the starting point. The application of this functionality can be applied to really any moving design, any linkages that you might think of. So when we talk about linkages, obviously the car suspension is an option, but we can also do things like create a bucket for a bulldozer, right? So any kind of equipment that needs to have multiple links on it, just a basic representation, and then we can see how multiple links will affect the design. So again, just some basic representations of links here, and then we'll just convert these each to their own block. So very quick process, just grab each of these, we'll go ahead and we'll make this a block, and we'll make the lower one a block, and then we need to decide on some points. And again, I like to use just the simple point if I'm trying to figure out a design and I don't really know the orientation of everything. I'll just throw sketch points in there and I'll lock them in place, and I'll let that start to drive my design. And once I'm happy with the locations of everything, I can start to use dimensions to figure out where those things should be. So now for this one, I'm going to go ahead and use the midpoint relation. But now what I have is a bucket, and I can see how that bucket is affected as things move up and down. So as we look at this, we can say, well, this point really needs to be a bit lower to get the motion that I want. And once it's in the right location, we'll lock it in place. So now the bucket comes up like this, and you can see that it actually stays more like a bucket. And if that's not working, then again, we can make some adjustments. Maybe we'll edit this link. We'll make it a little bit shorter, and then everything will update here. So now we can see that in order to get the bucket flat, it's down in this location, and then as we pick it up, it tilts and rotates now. Again, if that's not ideal, if that's not what you want, we just undo this fix, and we move these links around to a position that makes sense. And once we're happy with it, then we can start driving the design a bit more. So this functionality, by taking your mechanical designs down to 2D, use sketch blocks and create that mechanical motion, can help save you a lot of time from designing parts in 3D before you really know the layout and the geometry of what you're designing. Especially when it comes to planning out 4-bar or multi-bar linkage systems, even if they include gears or belts and pulleys to drive them, having this basic representation of that mechanical motion can save you guys a ton of time. As always, if you have any questions, please let us know. And if you have any ideas for topics or things that you want to see covered in these video series, please let us know that as well. And we're happy to cover as much information as possible as long as it's useful to everybody.